Well, welcome to StirCheck 2019. This is like one of my favorite conferences. I've never been to a conference with reclining chairs. So I guess I'm going to have to be like super entertaining so none of you fall asleep. But if you do, don't worry, I won't be insulted or anything. So our talk today, we're going to talk about AWS Cloud Map and Service Discovery. I entitled this talk, Dude, Where's My Service? As a play off of that old movie, Dude, Where's My Car? Horrible movie with Ashton Kutcher where they wake up one morning and they can't find their car, right? Well, I guarantee if you use Cloud Map, you'll never wake up one morning and not find your service, okay? So that's kind of the play with the title. A little about me, my name's Josh Wood. I'm a principal software engineer with the Insight Digital Innovation Team. For those of you who don't know about Insight, we used to be called Cardinal Solutions. We were acquired last year by Insight. I'm also a part-time adjunct instructor at Columbus State Community College. I teach object-oriented programming with C++. And that's my puppy Capone. He loves to play parrot dog. He actually enjoys being on my shoulder because he gets kind of the belly rubs. So he loves that. Okay. So this is an actual configuration folder from a project that I'm working now. Okay. That's not good. What is that? That's like 10 configuration files. Inside these configuration files, we're probably pointing to resources like database connections, possibly server connections, paths, and things like that. So we are like kind of segregating our configuration from our code, but at the same time, this isn't much better than hard coding. Because what happens if I make a mistake? I've got to change the configuration, I've got to redeploy everything. Okay, so I like to call this the infinity gauntlet. Because if you think about it, all it takes is one fat finger of a keyboard and snap your fingers, your system's down. Okay? So the idea of service discovery is we're going to move away from the static configuration model, and we're going to switch to let's discover our services rather than relying on hard coding. So for this talk, service discovery, we can actually spend all day talking about it. It is a very deep topic. So my goal for this talk is to give you some overview. Okay? Maybe you're just transitioning to the cloud. You're not quite sure if you trust this dynamic infrastructure you're getting. So I want to give you, stay out of the weeds. Let's give a very high-level discussion over service discovery. And then I will talk about AWS Cloud Map, how it's set up, how you can use it, how it integrates with AWS now, and how you can interact with it. And then I'm going to give a video demo of a cool little Marvel app I wrote for this, where service discovery helps me eliminate all the need for those messy configuration files. So at the very, very high level, service discovery is not tied to any type of resource. A lot of times we think about it as microservices. You hear it as just peanut butter and jelly, microservices and service discovery. But that's not really the definition. The definition is just the task of finding a service. Okay? It exists in Bluetooth. It exists in DNS. Okay? Microservices just kind of repurposed it for their usage. And the main benefit you get out of it is, like I said, it's that cultural shift from having static configuration files to just being able to ask where your resources are. Okay. So let's do some evolution. I'm not going to go through every scenario of service discovery, but this is when I was first introduced to it in the early 2000s. The idea was, our problem was we needed to locate a specific service. Okay. We knew it was coming up dynamically. How can we discover it? So we would actually send a multicast message out, and then we get all these responses back. So I would say, hey, I need service A, and every instance of service A would just barf back at me. And then I would have to do some type of load balancing, some type of round robin algorithm to then connect to it. So if you got here early enough, I gave you all a colored ball. So if you have a colored ball, I'd like you to stand up. And I'm going to announce a colored ball, and on the count of 3, you're going to throw them at my face as hard as you can. Okay? So everybody with the ball, if you have a yellow ball, I want you to throw it at my face. Huh? There we go. Think about how crazy this is, right? And I ended up only catching 2, and now I got to make a decision which one am I going to pick. So he's our winner. Okay? So he's actually going to be my service. I'm the client. I'm now going to talk to him. Okay? So that's the idea of like the older service discovery. So if you want to keep your balls, feel free. I got them off of Amazon. But that's kind of the demonstration, right? So we can see how unwieldy that was, right? Just think about if you had thousands of instances out there, okay? I had like 10 people throwing balls. Imagine thousands, okay? So the next step was we need to kind of abstract and encapsulate that logic, okay? So when I ask for that colored ball, I just don't want people throwing them all at me. I I need to have a little more control there. So the next evolution was you had an SDP client, which stands for Service Discovery Protocol. That's the message format. Clients and services, they both knew it was common between them. And the client would be embedded into your actual client that you were using for work, and then it would talk to an SDP server that knew where all the instances lived. So now instead of having all these balls thrown at your face, right, you're just talking to one person that says, here's the colored ball you want. Okay. So this is actually still pretty common approach in some networking today. But now we're starting to hear this resurgence, right? And what happens is the resurgence is now with microservices. It's now with your cloud infrastructure, okay? So what I want you to think about, in the cloud, the reason we use it, the first thing you get is high availability, right? How many nines does Amazon offer now? Is it 99.9999 on some stuff and 99.999999% high availability on other things, okay? Then you have auto scaling, right? That's when you're using these resources, as demand increases, we horizontally scale by adding more machines, or as demand reduces, we scale back, okay? So as high availability comes, where you're getting kind of like stuff coming up and stuff coming down due to healthy and unhealthy, and as your demand increases and decreases, this is dynamic infrastructure, right? You can't predict what you're going to have, okay? There's a lot of complexity there. It is now impossible to use static configuration. You could try, but I guarantee your life will be miserable because you're going to wake up one morning and your car's not going to be in your driveway, right? You're going to have to go and look through traces, figure out where the service is, okay? So how do we get around this? We get around it by asking where our resources are. We're going to discover where our resources are. As our resources come up, come down, they're just going to register their location to something that's all-knowing, okay? So in 2017, these were kind of the patterns. This is actually from an AWS Service Discovery white paper. And both of these are what we call server-side discovery. Okay? The first option was a load balancer. You'd go to a load balancer would route your request for you. Okay? The second one was DNS. You'd be able to register with DNS to different VPCs or networks, and then it would just route everything for you appropriately. That's still way better than static configuration, but we had some inefficiencies here. So when you think of microservices coming up and coming down, the load balancer has to reconfigure itself to be able to know. Okay, so you do get a delay. There is some outage there. The same goes with DNS. You're going to see a delay in that. So here's a video from HashiCorp, and this is kind of that load balancer DNS in video format. Okay? So if you look at the bottom, you'll see two bluish purple colored squares. Those are your services. Everything above it's a load balancer. And what this video is going to show you is, as that service comes up and comes down, you're going to see a delay as we have to reconfigure the load balancer. So you can see the load balancer is configuring itself. It notices there's a broken connection. It now routes, and service A connects to service B. No big deal. Uh-oh. Service B just went down. So now we have a delay as we update again to let service A then find service B. Okay, so it's still great. Don't get me wrong. This is a great approach, but you're still inefficient, right? Stuff is still not fast. When things go down and come back up, you have a delay as things re-register. So this is modern service discovery. Okay, this is actually taken from Console. It's one of the service mesh solutions out there, and it's the same idea. The services are now purple-red, but you'll notice as the service goes down and comes up, it's going to register itself with Console. Console's the C in the top middle. And then you're going to see service A, just ask console. And then you'll see a direct connection. So connection's broken, comes up, registers with console, and now service A just asks console. Where's that at? And then you see the two directly connect. Okay, that's the idea. We're not going through a load balancer here. We're going to console, and we're doing a direct connection. Okay. So now we're kind of in this scenario 3, where we still have the same problem. I still need to locate a service, but instead of relying on like an SDP client, or a bunch of balls thrown at me, I'm going to actually use something called a service registry. Okay? And when I think of a service registry, think of kind of like a dynamic phone book. Okay? You're going to be able to ask for my phone number, but you're going to get other attributes like my address. Okay? Or maybe you're looking for a store. You go to the Yellow Pages, you'll see their hours, things like that. So the service registry is just this dynamic phone book. It's all-knowing. It knows where all of your resources live. So we're just going to ask for it. We're going to say, hey, Dynamic phone book, where's service A live? And then it's going to give me the instances of service A. Okay. And this is what I like to call modern service discovery. This is where we're at now. Okay. It gives us two options. We still have that server-side discovery pattern, but now we also have a client-side discovery pattern. Okay? Both of these work, but when you think of client-side, think of that client directly connecting to the service it needs. And when you think of server-side, think about still going through that load balancer. So client-side, what are the pros? It's more efficient. Okay? There are also less components. You don't have to deal with configuring the load balancer or using DNS. You just have that client there. Okay? You actually get to choose your own load balancing algorithm. You could write your own. Okay? Maybe you're in a system where load balancing is not fast enough. You want to write your own algorithm. That's fine. And the clients have that direct connection, so you're not making multiple hops. Okay? The cons of it is you don't have inherent load balancing. Okay? There are some solutions out there that will load balance for you. Cloud Map's not one of them. Cloud Map will actually just return you every instance of the service that's healthy. Okay? And the other con is your client is now coupled to that service registry. Okay? You're relying on that service registry. And it's pretty easy to delete one in AWS, so you can have some major issues there. So when we look at the steps, step one of the client-side discovery pattern, those services come up, and they're going to register themselves with that service registry. Okay, that is their responsibility to tell the service registry all the info that service registry knows. Step two, the client is going to say, service registry, I need the location of service A. I need to make a connection. That service registry is, okay, here's all the info I know about service A. And then the client says, great, I want to connect. Okay? Pretty simple stuff, right? That's pretty easy. With server side, things change a little bit. Okay? With the pros, we're going to get that load balancing. Okay? I always trust Amazon and Microsoft more than I trust myself sometimes when it comes to stuff. But we get to use their load balancers. Okay? The best thing about it is your discovery details are now abstracted away from your client. Okay? So for those of you who are adjusting to a cloud environment, this one mimics closely what you're probably using now. Okay? It's just going to talk to that load balancer. And that load balancer is then going to route the request where it needs to go. Okay? The cons of this is you have more components in your pattern. Obviously, you've got more points of failure. You've got more things to manage and more things to configure. So that is a con. And then you still have a little bit of inefficiency, right? When we update a load balancer, that load balancer's got to reset and update its config. Okay? Same with DNS. So we have a little inefficiency there, but you need to weigh, is that inefficiency okay by decoupling from the client? Okay, that's up to you. Okay, it just depends on your situation. So the way this can work is there are actually two scenarios for server-side discovery pattern. The first is all discovery patterns are the same. Services come up, they have to register to the service registry. Okay. But in this version, what will happen is that service registry is going to work with the load balancer by using a template, for those of you who are used to Nginx or console, and it'll actually just update that template config, and that update's almost instantaneous. Okay, so now that load balancer gets updated as a services register. Then the client just sends to the load balancer. Okay, so the client has no clue yet where these services are. It just knows where the load balancer is. The load balancer knows where the services are. And then the load balancer is going to route the client request to the appropriate service. Okay. The second option to server-side discovery is, again, same thing. Services come up, they register to the service registry. But now what happens is the client contacts the load balancer. Load balancer has not updated yet. Load balancer then queries the service registry. Okay, it's going to ask for the location for that service, and then now it routes. Okay, so the difference is you can update your load balancer using something like console template or Nginx templates, or you can just let the load balancer query the service registry. Okay, you do have options there. So the one thing you probably heard me say a lot during those slides was service registry. Okay. Modern service discovery needs a service registry. And the reason why is as those services spin up, they know more about themselves than anything else. Okay. They're going to know their IP. They're going to know certain attributes like version. So we're just going to register all that with the service registry. So really all the service registry is a data store for service instance information. Okay? It's nothing too special. It's just a data store that you can talk to. The really awesome thing about service registries is they just don't support location. Okay? You could put whatever custom attributes in there you want. One example would be maybe you have a mobile app and you just want to update your registry and say, hey, mobile client asks for services with version 1.1.3, and then only those versions come back. So not only can you create your own custom attributes with service registries, you can query by those custom attributes. So you can set up a really sweet, custom, flexible, dynamic infrastructure using these. And again, when you're trying to put a mental picture to it, just think of a dynamic phone book. Okay, it's constantly changing, but it has a lot of attributes to it. There are a lot of offerings out there, and we'll see some more in a later slide, but I picked these three because Core DNS, as of Kubernetes version 1.13, is now the default DNS config for Kubernetes. Okay? Which means if you have just installed version 1.13 as a new install, you get service discovery inherent in Kubernetes. Okay? Core DNS became a part of Kubernetes in version 1.11, but it still used kubedns. Okay, you had to actually make it use Core DNS. And before that, you could still install Core DNS as a plugin. So if you are interested in Kubernetes, you want to see if it's a solution that works for you, install version 1.13 and later, you get service discovery for free. Okay. The other product, which is actually my current favorite, is HashiCorp Console. I am a HashiCorp fanboy. Console is not just service discovery, it's a service mesh. Okay, so with Console, you're not just getting the service discovery, you're also getting things like monitoring, alerting. They've got some really cool features around TLS. If you're in a legacy system and your legacy system doesn't support a certain version of TLS, well, HashiCorp Console will wrap that packet for you and make it that version of TLS. So service mesh is kind of this new evolution, and they just handle a lot of stuff for you, kind of like the Advil for infrastructure headaches. The problem with HashiCorp Console, it requires a lot of setup. It's very difficult to demonstrate in an hour talk. Okay? And plus, I want this to be an overview, and the best product I've seen to introduce you to service discovery is AWS Cloud Map. Okay? If you have experience with Amazon Web Services, your mind's going to be blown by how easy this is for Cloud Map to integrate. But it's also very flexible as well. It has interactions across all of the different SDKs and languages that AWS already supports. Okay, so it's very easy to get your feet wet with service discovery by using Cloud Map. So that's why I'm focusing this presentation on that. So what is Cloud Map? It's just a service registry. Okay. Knowing Amazon Web Services, it is a feature-rich service registry. Okay. There is no configuration required. It's there. It's platform. Now, you don't have to set up any infrastructure for this. Okay. It can register any application resource, and by any, I mean any. It can be stuff on-prem, can be on Azure, it can be on GCP, it can be on AWS, it does not matter. This is a fully customizable service registry. You can register your mom's phone number in there if you want to. Okay. It does not have to be a cloud resource. Okay. And again, it's already integrated in a lot of the AWS configurations that are taking off, such as Elastic Container Service, Elastic Kubernetes Service, all of that. It's all in there. And it works with stuff like DynamoDB, works with any of your relational database resources, works with S3. Okay? It's in there. And I've kind of already hit it on already. It's custom attributes. Okay, think of that. Think of a situation where maybe you're not in the cloud yet and you're just tired of hard coding IP addresses. You can still use Cloud Map. All you gotta do is register those IP addresses. You can still really loosen that coupling that you have to configuration, even if you're not ready to make that leap to the cloud yet. So the structure, think of object-oriented programming. Okay, when you think of Java, C#, right, we have namespaces, we have packages. It's like Python, we have packages. Okay? In Cloud Map, they have that similar structure. The namespace is a grouping of services. Okay, so think of that object-oriented programming namespace. And when you think of service, think of a class in object-oriented programming. Okay, it's kind of that blueprint. The service in Cloud Map is a blueprint of your service. And then the instances, those are the actual instantiation of those services. Okay? So you can have more than one instance of a service running, and Cloud Map knows about it. Okay? Cloud Map's going to track if that service is up or down for you. So if you ever query for it, you can just say, give me all the healthy, it gives you the healthy ones by default, but maybe you want to have a page where it shows you the unhealthy ones. You can ask for that. You can say, give me those unhealthy ones. Okay? You have complete query control with Cloud Map. As long as it's an attribute, you can ask for it by attribute. And I couldn't even fit all the integrations on one slide. This is everything it integrates with inside Amazon Web Service and external. Okay? It integrates with HashiCorp Console. You can make Cloud Map your service registry and console. You can make it your service registry in Istio, which there is a talk later today on service mesh and Istio. And then you can Tetrate. It's also a service mesh. It integrates with all those. And then look at all the AWS offerings that are up there. SQS, DynamoDB, Lambda, EC2, EKS, ECS. You're getting the idea. Amazon put a lot of thought into Cloud Map. For something, when you see it, that's visually so simple, it's amazing how powerful of a tool this is for you. So how does it interact with things? Okay. The goal of Cloud Map is just to loosen coupling with config files. Okay. We're pushing, anybody here heard of zero configuration? That's kind of our goal. We're pushing toward kind of this idea of zero configuration. Okay. The beautiful thing about it, it supports more than microservices. We just saw a pretty exhaustive list on that last slide. And then the key point of this is you can create these namespaces, these services, these instances. You can create them, or AWS integrations can create them for you. So you can set up your environment even if you're not in the cloud. Okay? So how can we interact with it? Okay. Of course, Management Console, you can go and actually use the GUI for AWS, but you can also use .NET, Java, JavaScript, Python, Node, Ruby. Okay. You can also integrate with AWS CLI, so you can query your register instances. Okay. And if you're a PowerShell person, hey, it's an AWS tools for PowerShell as well. So now you kind of have that DevOps kit as well. So now you can add this stuff to your pipelines really easy. But also as a programmer, you can use the SDKs, and now your services can ask Cloud Map through code by name where services are. Very powerful stuff. So let's look at our demo. Okay. So these are my requirements for my MVP. Okay. I want to create a website that's going to display a list of Marvel characters. Okay. We should be able to see an image of the character and a name, and then when I select that, I want to see a list of recent comics. Okay. I didn't have my product owner with me, so I just decided to do the past 2 years, 2018 to 2019. Okay. And then in that comic information, we should see an image of the comic, and then the description of what the comic's about. Okay. That's kind of the idea for this. Eventually, I could see it being a store because I can actually let you click into the Marvel store and buy the comic if you want to. But for my MVP, I just want to show the information. Okay. So for my infrastructure, the way this is going to work is Elastic Beanstalk is going to containerize my front end, my website. Okay. I'm then going to use ECS Fargate, so I'm going to do a serverless implementation of container orchestration. Use Elastic Container Service with Fargate. And in that, I have a cluster that has 4 services. Okay. It has a discovery service for anything external it can ask for services if it needs to. We have a character service, a comic service, and an auth service. Okay. You're probably asking, why do I have a service discovery service? Okay. Cloud Map is new. And the biggest hit right now is from a front end. You cannot directly talk to Cloud Map because they don't support cores yet. So while I did loosen coupling to services, I'm still coupled to the location of my service discovery service on the front end. Okay. I'm hoping they change that soon. But the good news is my other 3 services are not coupled to config. Okay, that character service, when you go into it, it's going to ask Cloud Map, where's my auth service? And it's going to connect directly to the auth service. Same goes for the comic service. Okay, so these services know each other's location by actually hitting Cloud Map directly. It's just my front-end code right now. Until they enable cores, we're kind of blocked there. Okay. Once those characters connect to Cloud Map, they're then going to connect to Marvel. Okay, so I've also registered the Marvel URLs inside Cloud Map. So those services, the comic service and the character service, are going to ask Cloud Map, hey, where's the Marvel API located? Okay. So again, my services have 0 configuration. There is a web config, but it is empty. Okay, it's just the default web config you get with .NET Core. Okay. And then Marvel developer APIs, anyone can sign up for that. It's kind of cool. Your only restriction is everywhere you use anything, a picture, you have to put below it copyright Marvel. but they do give you an API key, and it is pretty sweet, some of the information you can pull out of there. So since we weren't guaranteed internet in here, this is a video demo, so I'll kind of walk you through what's happening. I didn't cheat this. Okay? Trust me, I'm not a director. I didn't do any cuts and fancy editing. You can actually see by how clumsy I am by typing and my mouse usage that this is unedited. So I'm in my management console. You can see I'm going to click ECS here. My ECS is empty right now. I'm broke. I don't like to pay for a lot of stuff, so I create it as I need it. So I'm going to create a cluster, and I'm going to pick Fargate. Fargate's your default when you go into this. Okay. And now I'm just going to give my cluster a name. Remember, that cluster is just a bunch of services. It can be services and tasks in ECS. They're just similar to each other. And now when I created my cluster, now I need to go in and create my services. Okay. I'm going to create 2 of my services, and then I kind of jump ahead to do 4 because this will be a 20-minute demo if I didn't do that. So I'm going to create my auth API. That comes from Elastic Container Registry. Anytime you use containers, you need a registry. Like I said, I have to pay for this myself, so I'm only spinning up 1 task to save money. And then you can see right there, it's already integrated. It's already checked. You're getting this for free in ECS. You have to opt out of service discovery now. It's part of your ECS packet. When you create a service, it's part of it now. It's inherent. Then I'm going to get it on my network. You'll see I care a lot about security because I'm going to go straight to the default security group, and I just open everything. I didn't want any headaches, so I did this demo. Luckily, this is not a talk on security. And then I just wanted to show you an information bubble here where it tells you what the namespace is. And then I got local private. Private means only my network can access it. Okay, so I do have some security in place. And then I'm going to go to my next step. I'm not going to scale up or scale down because, again, I have to pay for this. And now I'm just going to create my service. So you'll see right there, service discovery service. It's been created. And we're on to the next one. Okay, so we're going to repeat it one more time. Come on, clumsy. Yeah. So I'm showing you that the service is pending right now. Great. And now I'm going to create my second one. Okay. These steps just retrace themselves. I wanted to do that because when I post this slide for everyone later, I just want to make sure you didn't have to keep rewinding. So I go through the steps again. But this time I'm going to create my character API. Again, name it something cool, like Star Trek Demo Character API. 1 task, and then I go to my next step. And again, see it? It's checkbox. It's already checked for me. All I have to do now is, since I do have a private namespace, I've got to get that service on my network. So I pick my current cluster VPC. I go ahead and I don't care which one of my subnets it goes on, just pick one. And now my super concrete lockdown security group that only allows all connections from everything. And then you can see there's health checks in there. Okay. And again, going straight, I'm going to create my service instance, and I'm going to use DNS. The cool thing about DNS with Cloud Map is if you use that as an option, you get health checks for free. Okay. It's actually going to use DNS, and it's going to run some health checks. So that's how it knows that your instances are up or down for you. And now this service is created. And you're going to see a jump in time here in a little bit where all of a sudden you see 4 services. All I did was the same steps for 2 more. Okay? I didn't want to bore you with that. And you'll see my services are provisioning. I believe I'm very patient here, and I refresh 5 times to watch that service come up and down. Again, I didn't pick the best of hardware here. I went the cheapest route. So I have a very slow Fargate instance here. As you can see, it goes from pending to activating, and then it's still activating. I count to 15. I refresh again, still activating. Well, you know what, just trust me. And then it's like, okay, one more time. Oh, dang it, it's still activating. And now magically it shows up as active, I believe. And it's running on this one. There you go. So now I have my 2 services running, and then suddenly I snap my fingers, I've got 4. Okay. So that's the steps. That's really easy. right? I did not have to do anything special. I could have just hit next, 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 and got my service with Service Discovery. Okay? Very easy to use and integrate into AWS. And I wanted to show you, I'm asking for one service, I get one service. I could have created 10 services. I could have put scaling in, scaling down. Again, this goes against my personal credit card. I don't want to do that. But you can. And it's going to keep track of all those instances. Because when you think of the Cloud Map structure, remember it's namespace, service, and service instances. So it will keep track of multiple instances for you. It's smart enough to do that. So you can track different versions. You can track any task that that service needs to run. You can task all that. Okay. So now let's look at the front end. I am not a UX specialist, so please be nice. But you can see I click the vision character, and now you'll see I'm just using a simple tile format to show the comic images. Marvel, if you're watching, I have your copyright information in each one of these. And then some descriptions. Okay. And now I'm just going to navigate through these. Thanos does have a bug here, so please be gentle. Apparently there's a comic that's description so long it pushes the title off the tile, so just ignore that. But overall, I mean, you're kind of getting the idea here. There it is right there. There's the bug. Right. And the cool thing is that I'll show you here in a little bit is I'm actually going to stop the service and spin up a new one, and you'll see that the front end just has a little bit of a delay as that service comes online, but I never have to change anything on the front end. Okay. So that's what I'm doing now. I'm actually going to go into my cluster, my Fargate cluster. My character API is the most important. That is the one, excuse me, that is the one that starts everything. Without the characters, I don't have any content. So you know what, I'm going to, in production, I'm going to pull a Netflix and I'm going to take this sucker offline. The 10 users currently seeing my front end are down. But the good news is Fargate's going to recognize this as a stop task, and since I asked for at least one, Fargate spins up another one for me. Okay. So I never have to actually start another service. As soon as this one goes to deprovisioned, I will get a new one. There we go. So my character API, version 13, you can probably tell it's a different task number. It is now ready. So I go back to my front end. I go back to Vision. Oh, actually I went to Hulk. Okay. So you see a little bit of delay here. This is Fargate. Okay. Since Fargate's serverless, it's cold right now. So this delay is actually warming up my service. And now everything works again. I didn't have to redeploy. Imagine if that was static configuration. You would have to run another deployment just to update configuration. And that's a headache. If you're not fully CI/CD, where you can release on demand, that's a headache because you probably have some bureaucracy around deployments, right? That is the front end demo. So now let me show you what Cloud Map looks like. It's a very easy visual. So I'll click into AWS. You'll see my namespaces. Shared is kind of like my educational namespace. That's how I learned it. I just chose API calls. That's purely custom attributes. I have no integration with AWS with that route. So for this one, you'll see I integrated with DNS. So now I get health checks. I get the full feature set from Cloud Map. And you'll see my 4 services are in there. The one thing I wish console had right now is the ability to see your instance from Management Console, and you cannot, unfortunately. I don't know why they do that. Hopefully that screen's coming soon. Like I said, this was just announced at AWS in late 2018. So I'm hoping that comes soon, but don't worry. You can still see your instances if you use CLI or any of the SDKs. You can grab those details. So what I'm showing you now is my CLI. Hopefully everybody can see that. I'm just using the AWS Service Discovery CLI. And all I'm doing here is saying, hey, for all my instances that are part of the local namespace with a service name, Star Trek, Demo Auth API, give me the details. Now this is all the stuff that AWS gave me for free. You can see we have healthy, we have a private IP address, we've got the cluster name, we've got the service name, we've got the task definition family. It tells me what region it's in, and it tells me what availability zone it is. Okay? I got that all from that checkbox. Remember the checkbox? Checkbox gave me all that. So now I'm going to query my demo character API. If you look real close, you'll see the APIs or the IPs of both of those tasks are different. You can see it's still tracking healthy for me. And then I go ahead and I do the comic API as well. So you can get that information, you just have to do it through CLI. at this point in time. I'm pretty sure Amazon will add that here in a little bit. So let's go back to those benefits. Okay? I've thrown a lot at you. First benefit is pushing you towards zero configuration. Right now, it's not quite there. Remember my front end? Right? I still have a little configuration, but I have loosened that configuration. If you think of everything you can put into Cloud Map, again, data storage, okay? EC2 instances, right? Clusters. You can put all that stuff in there. You are loosening that coupling to that awful configuration file. Okay? You also get inherent health checks and failover. Okay? It knows when stuff's up and down. It relies on the service to tell it that. It knows. So you benefit from that. And the one thing I want you to think about is the cloud and that dynamic infrastructure is complex, okay? But it's also very flexible. Okay? So I want you to think about how can you harness the power of that flexibility. Okay? This service registry, service message, service meshes, service discovery, they give you options to easily do blue-green deployments now. You don't have to be afraid of clicking the deploy button anymore because you can still have that second environment for failover. Okay? You can do canary testing. Maybe you just want to send it out to a few users at first, and then more users, and then more users, and then more users. You can do that because, again, you're not configuring anything. As the stuff comes up, it configures itself. Okay? And then maybe you're in the mobile realm where A/B testing or split testing is a pattern because you're not quite sure. You're cramming all that content on one screen. You're not quite sure what your users would like best. You can do that, okay? Just by using the service registry. So what I wanted to do was, if you like this talk, okay, I picked 3 other talks today. The next talk in this room is actually going to talk more into detail about the demo. It's not my demo, but the stuff I use in the demo. So you're going to see ECS, EKS. Okay, you're going to see a deep dive into those. Okay, and Andrew May is running that one. He's in this room. So if you're in the telecast rooms, just stay there if you're interested in this stuff. Okay, and then Jonathan J. Tower, he's doing a talk on ASP.NET Core around is it ready? Is it enterprise ready? Okay, I picked .NET Core because that's what I wrote my services in. I'm a C# dork. I can't help it. Okay. And then Granville Schmidt has a service mesh discussion around security compliance. Service mesh is that next step of evolution into handling this dynamic infrastructure. Okay, so I think his is going to cover Istio, which is one of the service meshes that was on that slide, but Console is also another service mesh, and Tetrate as well. So he'll talk about service meshes. And if you want to take a picture of my email address, send me an email, and I will give you the link to the slides. Okay. Again, this video will be posted on the Stir Trek channel in YouTube. But I believe that's coming in May, so there might be a little late May, so there'll be a little delay there. But feel free to email me. I will return all responses. If you want business cards, come up to the front. I've got a handful of those that has my cell number and email in there if you ever want to contact me with questions. And about questions, do we have any? These are, I wonder this, are fish thirsty? I always wonder that. And personally, I think the dog wears the pants on the right. Any questions from the rooms? It's ripped, likes to show off. You got anything from Slack? Well, that's all I had for you. Thank you very much for your time. I appreciate not throwing any rotten fruit at me or anything. And I'm happy all of you stayed awake.